common denominator. So when you add or subtract rational expressions, here are the steps I want you to follow. So adding or subtracting rational expressions. Step number 1. This will be sweet if this was the case every time, but it's not. So step number 1 states, if the denominators are the same. Then all you are going to do is add or subtract. Ooh. Oh, that was close. That was close. That's close. I think we're all safe. We're going to add or subtract the numerators. Then you'll place the result over the common denominator. So if that's the case, I'm going to do a silent fist pump in my head. I'm going to think, all right, I don't have to do any work. So then all you do is just add your numerators, combine your like terms, and then put them over whatever that common denominator is. Okay? Life's not that easy. So what happens when we don't? So if the denominators are not the same, if the denominators are not the same, then you'll find the least common denominator. You'll write all rational expressions with this least common denominator. And then continue the above. So once we have a least common denominator, then our denominators will be the same. Then we can add or subtract the numerators and then place the result over the common denominator. And then our last step is to simplify, which we practiced simplifying back in section 7.1. The whole process of simplifying is canceling out any like factors that you can to take it to its lowest terms. Okay. All right, so we're going to do a few first that do have a common denominator before we step to the harder problems where we do not have a common denominator. And then we're going to have to find a common denominator. And it will not be as easy as find the common denominator of 2 and 3. Okay, it'll be a little bit more challenging. All right, so here we go. Problem number 1. Here are your 2 rational expressions. 3y over 5 plus x over 5. Do they have a common denominator? Yes. They have a common denominator of 5. Do not add your denominators together to make 10. When you add fractions, the common denominator just stays in your denominator. So 5 will stay in my denominator. Now I'm going to add the numerators. 3y plus x. Are there any like terms in those numerators? Nope. So then I'm just going to rewrite it as 3y plus x. Answer.
That's it.
That's it. If there were like terms, then I would combine them together to simplify it. Okay. I can't factor this any further. I can't factor this. So I'm done. Can't simplify anything out. Okay. Drive-by homework assignment shooting. All right, so next one. 7 over 2r squared minus 11 over 2r squared. Do we have a common denominator? Yes. So my resulting answer is going to have 2r squared in my denominator. Now let's either add or subtract the numerators. Well, here they are like terms, so what is 7 minus 11?
-4.
So we get negative 4 over 2r squared. Now to go back to the beginning of section 7.1, can I simplify that? Yeah, I don't have any r's, so the r's aren't going to be affected by anything, but negative 4 divided by 2 is negative 2 over 1. So I get negative 2 over r squared. And that would be your final answer. Questions with that one? So far, so good? All right. Next one, getting a little bit more funky. So I have m over m squared minus p squared plus p over m squared minus p squared. Do we have a common denominator? Why, yes, we do. So my resulting fraction is going to have m squared minus p squared in the denominator. My numerator is going to be m plus p. Now, why am I starting to get excited? We can factor that m squared minus p squared, right? That's a difference of squares. And the reason why I'm going to factor it is because I need to check to make sure that this is in the least or the lowest common terms. So I want to check to make sure there aren't any factors that I can cancel out. So that goes to m plus p, oh boy, times m minus p. What goes away?
M plus P.
The m plus p's cancel from the numerator and the denominator. So what's left over? Yeah, there's
M minus P.
1 over m minus p. Perfect. Just because there's nothing up there, you don't put a 0. You got to put something as a space filler, which is going to be 1. Okay. All right, let's do one more like this, and then we'll go to the more harder problems. Everybody ready? Okay. So we have 4 all over x squared plus 2x minus 8 plus x all over x squared plus 2x minus 8. So my denominator is the same, so I'm just going to transfer that over. X squared plus 2x minus 8. Adding my numerators gets me a 4 plus x. Now I want to make sure I can simplify it further. So let's factor this. What are factors of negative 8? That get us to 2.
-2 and 4.
Negative 2 and positive 4. My leading coefficient is 1. So that goes to x plus 4. Oh, I did it backwards.
Wait, there's an order.
No, it doesn't matter what. I just listed negative 2 first, and then I put plus 4 first. Is this the same as this? Yeah, the commutative property allows me to just flip it because the plus sign makes it a-okay. So those cancel out. So all I'm left with is 1 over x minus 2. All right. So now, what happens when they're not the same? So that means we got to find the least common denominator. I have steps here or not? No, we don't. Okay, so here we go. 5 over 2p plus 3 over 8p. Not the same denominator, but close. So let's focus on the variable first. They both have a p, so that's good. But this one has an 8 and this one has a 2. So what can I do to 2p to make it become an 8p? Multiply it by 4, right? 2 times 4, yeah. So if I were to multiply this by 4, then that denominator would be an 8p. And this denominator still would be an 8p. Is the numerator going to change on the second fraction? No, that's going to stay a 3. Is the numerator going to change on the first fraction? Yes, because to keep it balanced so that I don't completely change the problem, what I do to the denominator I must also do to the numerator. So that goes to 20 over 8p. So what's going to be my final result? When I add them, 23 over 8p. Can we simplify the 23 over 8 at all? No. If it was 24, then we could simplify that, but we can't simplify 23 over 8. Okay? So that one was pretty easy. How about this one? 6 over r minus 5 all over r minus 3. Now you may just think, wow, this is Crowley. Can't I just add a minus 3 to the problem? No, you can't do that. Don't just add a minus 3 to make it look like the r minus 3. Okay, to find a common denominator, you have to do multiplication. You have to find the least common. So, when your denominators are two totally different things, the easiest way to get your common denominator is to multiply either side by each other. Right? Over here we had a 2, here we had a 3. To find the common denominator of 6, I multiplied the 2 by this, I multiplied the 3 by this. Okay, so the same thing applies when we're doing algebraic expressions. So what I need is to have both an r and an r minus 3 in my denominators. So what I'm looking for in my two denominators is to have an r times an r minus 3. And that's going to be my common denominator. Because what do both denominators have? The one has an r, and the other one has an r minus 3. So now I need to think about what just happened. For the first fraction, I already had the r, but what I was missing was the r minus 3. So that means I need to multiply my numerator also by the r minus 3. So if I canceled them out, I would get right back to my 6 over r. Now let's go over to the other fraction. Here I already had the r minus 3. I was missing the r, so that means I need to multiply that 5 also by an r. Is everybody okay with that step? Okay, so now my denominator is the same. So now my resulting fraction will be r times r minus 3 in my denominator. In my numerator, I'm going to have 6 times r minus 3 minus 5r. No, you cannot just cancel out that r minus 3. You can only cancel things out when something is in completely factored form. I see a subtraction sign. Completely factored form means everything's being multiplied by each other. So let's simplify my numerator. Distributive property. So I'm going to work up here. 6r minus 18 minus 5. Negative 18 and negative 5 combines to make, what, negative 20? Oh, 5r. Never mind. Thank you. So 6r and a minus 5r would be 1r. 1r minus 18. Can I factor out a GCF or anything out of that? No. So I can't cancel out my r minus 3s. I can't cancel out an r. So my end result will be r minus 18 in my numerator, all over r times r minus 3. That's in the most simplified form. Yes?
Will we get an answer wrong on the test if we distribute the denominator?
If you do, no, I won't take off. Just to make my life easier for grading wise, just leave it. And then it's less work too.
All right.
But yeah. Okay. All right, let's do another one. A little bit more challenging. Oh, that was not challenging. That one's better. So 1 all over q minus 1 minus 1 all over q plus 1. So I'm looking for a denominator that's going to have both of those factors in it. So that means I just need both of them. So I need a cube minus a 1, and I need a cube plus a 1. I need a cube minus 1, and I need a cube plus 1. So what am I originally missing in the first fraction? I'm missing the q plus 1. So I'm going to take that 1 and multiply it by q plus 1. In my second fraction, I'm missing the q minus 1. So I'm going to take that 1 that's already in the numerator and multiply it by q minus 1. So now my denominator is q minus 1, q plus 1. Now let's be careful here. Distributing my 1s is not going to affect those expressions, so my first numerator will just be a q plus 1. But now I need to be careful. Here I am distributing a negative 1, technically. So if I distribute a negative 1, that q is going to become a negative q. And distributing that negative 1 to a negative 1 is going to make it become a positive 1. So what does my numerator simplify to? 2, right? Because your q's go away, and then you have a 1 plus a 1, so you would have 2 all over q minus 1, q plus 1. Answer. All right. Let's end with a really good one. I'm going to skip through to the hardest one. Then we'll do some practice. Oops. Last one. Go back. All right, here it is. 5 all over x squared plus 10x plus 25. And then 2 all over x squared plus 7x plus 10. So do not do this. Don't say, oh, well, Mrs. Crowley said I need to have both on either side. So I'm going to have an x plus 10x plus 25 over here. And then I'm going to also need an x squared plus 7x, don't write this because this is not right, plus 10. So then I would do 5 times x squared plus 7x plus 10. I mean, technically, yes, you could do that. That's going to make it a lot more work than you need to. So what I would do, if I notice that I do not have any factors right away, I would factor both my denominators. What are factors of 25 that add up to 10? 5 and 5. So this goes to an x plus 5, x plus 5. What are factors of 10 that get you to 7? 5 and 2. So x plus 5 and x plus 2. All right, so now let's think about what do I need in my denominator. Well, this side has 2 x plus 5s. This side only has 1 x plus 5. So that means I'm going to need to add another x plus 5. This side has an x plus 2. This side does not have an x plus 2. So all of the factors that I'm going to need for my common factors are the following. I'm going to need 2 sets of x plus 5s. That's what this side has. And the only other thing that's over here that's not part of this would be an x plus 2. So my denominator is going to have 2 x plus 5s and an x plus 2. So I'm going to reproduce that on the other side.
Why isn't it 3 x plus 5s?
I mean, you could do 3, but then you'd be doing more work than you need to. You want the least amount of common factors. I mean, you could do it that way, but then you would have more.
Why you wouldn't.
Well, okay, so if
that 1 x plus 5 evaporates.
Okay, so just watch this then. Don't write this. If I put in the third one, so if I put in another,
I would know what to do if there was a third one, I just don't know what happens to that third one, why you aren't including it. I just don't know why you aren't including it.
Because it's not necessarily necessary. If I add the third one in, just watch for a second, and then maybe it'll make sense once I put it in there. So if I add the third one in, and I have my denominator of 5, so what's missing? I'm missing an x plus a 5, and I'm missing an x plus a 2, right? Because that was from the other side. Well, I have one x plus 5 up down here, and 2 of them down here. So I have, if I cancel out these, then I'm left with just the 2 again. So it's like having an extra x plus 5, which means you're just going to have more things that you're going to have to multiply.
Since you're actually canceling it before writing the rest of it. Okay.
Yeah, because I mean, you could do it that way, you're just going to have more numbers that you need to multiply out. And we want to try to have the least amount of work that we need to do. Okay? Alright, so it is there, but we canceled it.
Okay.
So what's missing is only the x plus 2. So I'm going to add that to my numerator. Over to the other side, what do I have missing? Well, I have an x plus 5, check. I have an x plus 2, check. I don't have the second set of x plus 5, so I need to bring that into my numerator. Alright, so now let's go ahead and do some distribution. I'm going to distribute right here above them. So 5x plus 10, distributing a positive 2 to my x plus 5 gets me 2x plus 10. So what's my numerator going to go to? Good, 7x plus 20. And that's going to be all over, and I'll just list out those 3 parts. X plus 5, x plus 5. Or if you wanted to write it as x plus 5 squared, that would be okay. And an x plus 2. Can I cancel out or factor out a GCF out of 7x and 20? No, I can't. Okay. What would have been nice is if this was like a 4, then we could have taken it out and canceled stuff out. All right, do you want to just get working on your homework, or do you want to do some practice problems? Just start working on your homework? Okay, so I'll start throwing those problems up on the board.